You ever open up one of your old coding projects and just stare at it? It feels like walking into a messy workshop, right? Tools are everywhere, nothing's labeled, and you end up spending more time just trying to find the right screwdriver than actually building anything. If that sounds even a little bit familiar, you are in exactly the right place.
Because today, we're going to clean up that workshop for good. We're diving deep into one of Python's most powerful secrets for staying organized, modules. This is how you go from that tangled mess to a clean, super efficient, professional-looking codebase.
So here's our game plan. First up, we'll get clear on what modules actually are. Then we'll get into the art of importing them, bringing those tools to our workbench. After that, we're going to get our hands dirty and actually build our own. And to wrap it all up, I've got a fantastic pro tip that's going to make your code way more versatile. Let's do this.
Okay, so first things first. What in the world are we even talking about when we say modules? Well, think of them as the absolute bedrock, the fundamental building blocks for any organized Python program.
And honestly, it's way simpler than it sounds. A module is just a file. That's it, a single Python file with a .py extension. The best way to think about it is like a specialized toolbox. So instead of just dumping all your tools, your functions, your classes, your variables, into one giant, messy heap, you start grouping related tools into smaller, neatly labeled toolboxes. You've got one for math stuff, another for handling dates, and maybe one you made yourself for custom greetings.
So why even bother with all this? Well, the payoff is huge. First, it just makes your projects make sense, It lets you write a really cool function one time and then use it everywhere, which means you're not copying and pasting the same code 100 times. And maybe best of all, it gives you the keys to unlock this massive library of tools that Python already has built right in.
And speaking of those tools, you'll generally run into three main kinds of toolboxes. First, you've got your built-in modules, like math or datetime. These are the standard tools that come with every single Python installation. They're already waiting for you in the workshop. Then, you've got third-party modules, like NumPy or requests. Think of these as specialized tools you order online, with pip. And finally, and this is the really empowering one, you've got user-defined modules. These are the custom toolboxes that you build from scratch.
Okay, so we've got all these amazing toolboxes sitting around. How do we actually open them up and start using what's inside? Well, that brings us to the art of importing. The most direct way is with a simple import statement. When you type import math, you're basically telling Python, hey, go grab that entire math toolbox and bring it over to my workbench. Now, here's the key. To use a tool from it, you have to be specific. You have to say which toolbox it came from. So you write math.sqrt. That's the toolbox name, a dot, and then the tool name. It's super clear, totally explicit, and you never have to wonder where your functions are coming from.
But what if you don't need the whole box? What if you just need one specific wrench? Well, that's where from.import comes into play. Writing from math import square root is like reaching into the math toolbox and putting just the square root function directly onto your workbench. The upside, your code is cleaner, more concise, you can just type square root 16. The potential downside, if you import two tools with the same name from different toolboxes, well, things can get a little confusing. So it's always a trade-off between clarity and conciseness.
And here's a great little shortcut for when you're dealing with modules that have ridiculously long names. You can give them a nickname, or what we call an alias. By writing import datetime as DT, you're just telling Python, hey, for the rest of this file, let's just call this thing DT. It's the same exact toolbox, just with a shorter, more convenient label. You'll see this all the time with popular libraries like NumPy and Pandas.
All right, we know how to use other people's toolboxes. Now for the really fun part. Let's start crafting our very own. This is where you really start to level up as a developer, moving from just using code to creating reusable tools.
And you want to know the best part? It is not complicated. A user-defined module is nothing special. It's just a standard Python file, any file that ends in .py. You write a few functions you think you'll need again, you save the file, and that's it. Boom, you've just created a module. You've built your very own toolbox.
Let's make that super concrete. Imagine you create a file. You call it greetings.py. And inside, you write a function called say_hello. Now you go over to your main project file, maybe main.py, and at the very top, you just write import greetings. And just like that, you can now call greetings.say_hello. And it works perfectly. You have officially organized and reused your own code. It's that easy.
Okay, for our last section, let's pull back the curtain on a true pro-level technique.
Think of this as the secret switch that makes your custom toolboxes incredibly powerful and professional.
So I'm sure you've seen this weird-looking line of code somewhere. If _name _equals _main. It looks pretty cryptic, doesn't it? A little intimidating even. But what is it actually doing? And why does every experienced Python developer say it's a best practice? Okay, here's the secret. Every single Python file has this hidden, built-in variable called _name_, and the value of this variable changes depending on how you use the file. Scenario 1, if you run the file directly, like from your command line, Python sets that file's _name variable to the special string _main_. But, scenario 2, if you import that same exact file into another script, Python sets its _name to its actual file name, like greetings.
So what that if statement is really doing is just asking a simple question. Hey Python, is this file being run directly by a human, or is it being imported as a tool into another file? And the code inside that block will only run if the file is the main program. This is absolutely brilliant. It means you can stuff that block full of test code, examples, or little demos of your functions, and you never have to worry about that code accidentally running when someone else imports your file. It lets your module be both a library for others to use and a runnable script for you to test. It's a dual-purpose masterpiece.
And that's a wrap. We've basically gone from a tangled, messy workspace to a clean, well-organized professional workshop. Let's just do a quick recap of the key tools we've added to our collection today.
So what do we cover? We learned that modules are really just Python files that help us organize and reuse our code. We saw the 3 big types, the ones that come with Python, the ones you install, and, of course, the ones you create yourself. We mastered the different ways to import them. Import, from import, and as, so you can pick the right one for the job. And we unlocked that pro-level best practice of using if name equals _main to build flexible, testable code.
I want to leave you with this thought from the legendary B.B. King. Mastering concepts like modules, it isn't just about writing cleaner code. It's about investing in a skill, a tool that becomes a permanent part of who you are as a developer. It's something you build, something you own, and something you can use to create absolutely amazing things. Now, go turn that messy workshop into a masterpiece.